This is a truth table. Truth tables are a convenient way for organizing the truth values of statements. Truth tables can be used to determine the values for negation, conjunction, and disjunction. First, make columns with headings that include each statement, negation, and the compound statement. Then, list the possible combinations of truth values. Finally, use the truth values for each part of the compound statement to determine the truth value of the statement. Here is an example of a table that includes two compound statements. Just like before, make columns that state each statement, negation and compound statement. Then, list the combinations, and finally, use those combinations to determine the truth value. But wait! What are those weird symbols? When should I use them? Those symbols symbolize conjunction versus disjunction. A conjunction is when the statement uses and. For example, if Sally brushed her teeth and went to bed, then the statement is true. The statement is true only if Sally brushed her teeth and went to bed as well. A disjunction is if the statement uses or. For example, if Sally brushed her teeth or went to bed, then the statement is true. The statement is true if she either went to bed or brushed her teeth.
Law of detachment. If P then Q is a true statement and P is true, then Q is true. For example, if you don't do your homework, then you will get an F. You didn't do your homework. Conclusion, you got an F. Law of syllogism. If P then Q and Q then R are true statements, then P then R is a true statement. Example, if you buy lunch, then you will eat lunch. If you eat lunch, then you won't be hungry. Conclusion, if you buy lunch, then you won't be hungry. Modus tollens. If P then Q and Q didn't happen, then P didn't happen. Example, if I work, then I earn money. If I didn't earn money, I didn't work.
This is a two-column proof. Proofs are used to prove theorems and statements throughout geometry. In this proof, we are given the fact that ABC is a right angle. We are trying to prove that angles 1 and 2 are complementary. First, we can say that angle ABC is a right angle, because we were given this. Second, we know that angle ABC is equal to 90 degrees, because of the definition of a right angle. Third, we know that angle ABC is equal to the measure of angle 1 plus the measure of angle 2, because of the angle addition postulate. Fourth, we know that 90 degrees is equal to the measure of angle 1 plus the measure of angle 2, because of substitution. Finally, we know angles 1 and angles 2 are complementary angles because of the definition of complementary angles.
Truth tables was our free choice because it's not that hard to pick up and you just need to make a table of all the possible combinations of whether something is true or false. We chose the law of detachment, the law of syllogism, and modus tollens for our hardest topic because each of them have very similar definitions with a bunch of P's and Q's, and it's easy to get mixed up if you don't know which one's which. We chose proofs for our most important topic because you can prove theorems and properties of shapes plus other things. They take you from I think I know to I know because you have to use definitions and postulates, which are things you know to prove why a statement is true.